All right, welcome to the explainer. So, what if I told you that being super consistent doesn't actually mean you're right? It's a bit of a head scratcher, right? Well, today we're going to dive into the critical difference between two words you probably use all the time: accuracy and precision. Okay, so to get started, we've got to bust a really common myth that messes people up when they look at data. And that's this idea that you can get a perfect measurement. So, just imagine this. You're in a lab, right? You measure something 3 times in a row, and boom, you get the exact same result every single time. That feels pretty good, doesn't it? You'd think, nailed it, my measurement has to be correct. But is it? Yeah. Well, the answer is sometimes. The truth is that perfect consistency could actually be hiding a big problem, and figuring out why really gets to the heart of a key idea for anyone who wants to understand science or honestly just make sense of the world. So, to really wrap our heads around why consistency isn't the whole story, we first have to get comfortable with one simple but really powerful idea: uncertainty. Look, in science, no measurement is ever 100% exact. It's just not possible. Every single tool we use, I mean from a basic ruler to a crazy advanced satellite, has its limits. Our own eyes aren't perfect. That's why the goal in science isn't to be perfect, it's to understand and, account for that uncertainty. And you gotta understand, this isn't like admitting you messed up. It's actually the opposite. It's about being really careful and honest and just clearly saying, hey, here are the limits of what I was able to observe. And this uncertainty, it can sneak in from everywhere. Think about it. The little lines on your ruler aren't infinitely small. Maybe you read a dial from a slightly different angle. The temperature in the room might change by a tiny bit. All these little tiny things, they all add up. So if every single measurement has this little bit of uncertainty baked in, how do scientists ever evaluate their data? Well, this is where two very important tools come in. They sound super similar, but they mean totally different things: accuracy and precision. Okay, let's really break this down. Accuracy, that's all about hitting the bullseye. It's how close your measurement is to the real accepted value. But precision, that's about consistency. It's how close your repeated measurements are to each other, no matter where they are on the target. And this target visualizes it perfectly. You can see the four possibilities, right? The top right, that's the dream. Your shots are all clustered right on the bullseye. That's both accurate and precise. But now look at the bottom right. See how all the shots are clumped together, really tight? That's high precision, but they're nowhere near the center, so that's low accuracy. And then you've got the top left, where the shots are kind of all over the place, but they're scattered around the bullseye. That's accurate on average, but not very precise at all. And this leads us to probably the single most important thing to remember from this whole explainer. Precision does not guarantee accuracy. Just because you're consistent does not mean you're right. You could just be consistently wrong, making the same exact mistake over and over and over. All right, enough with the theory. Let's make this real. To see how this all plays out, we're going to look at a classic example with two students doing the same experiment. So, their job is to measure the boiling point of water. Simple enough. And we know the scientifically accepted true value is exactly 100 degrees Celsius. So that's our bullseye. That's the number we're aiming for. Okay, so our first student, we'll call them student A, gets to work, carefully runs the experiment, and takes 3 different readings. And here's what they get: 99.9 degrees, 100 degrees flat, and 100.1 degrees. Now just look at those numbers. They are super close to each other, and they are all hovering right around that true value of 100. So think back to our definitions. How would you describe this data? Is it accurate? Is it precise? Or maybe it's both? You got it. It's both. The results are really close to the true value, which makes them accurate, and they're all tightly clustered together, which makes them precise. This is basically the gold standard for experimental data. It's exactly what you want to see. Okay, but now let's check in with student B. This student is using a different thermometer, but doing the exact same experiment. Whoa, okay, look at these results. 95 degrees, 95 degrees, and 95 degrees. Every single reading is identical. I mean, you literally cannot get more consistent or repeatable than that. So, what does this tell us? Based on these numbers, is this good data? Is it accurate? Is it precise? What do you think? Well, the measurements are incredibly precise. I mean, perfectly consistent. But they're consistently wrong. They're way off the true value of 100 degrees. This is a perfect example of what's called a systematic error.
most likely from a thermometer that just wasn't calibrated correctly.
And this example right here brings us full circle. It perfectly shows why this distinction is so important, and not just in a science lab, but, well, pretty much everywhere.
So let's sum it all up. Here are the key takeaways. First, we have to accept that no measurement is ever perfect. There's always some uncertainty. Second, to really judge data, you have to ask two different questions. Number one, how close is it to the real truth? That's your accuracy. And number two, are the results repeatable? That's your precision. And the big one to always remember, just being consistent is never, ever enough.
And once you start thinking this way, it makes you a much smarter, more critical consumer of information. So the next time you see a news report with a really specific statistic or a study that has super consistent findings, you can take a step back and ask, okay, is this data actually accurate or is it just precise? Is it really hitting the bullseye or is it just hitting the same wrong spot over and over again?